On a quiet winter night in 1973, the unthinkable happened. An eruption so sudden and so close to civilization that it could have wiped out an entire town. But what followed next wasn't just a disaster. It was one of the boldest and most ambitious disaster responses in history. Iceland decided to fight fire with water, literally, by pumping seawater into an active lava flow. Let's rewind a bit. It all started on January 21st, 1973, when a series of small, almost imperceptible tremors began to shake the earth beneath Heimaey, the only inhabited island in Iceland's Vestmannaeyjar archipelago. These early quakes were so minor that most residents didn't even notice, but something much bigger was brewing underground. That night, seismic stations picked up over 100 significant tremors within a 2-hour window. Still, no alarms were raised. After all, minor earthquakes are routine in a geologically active country like Iceland. No one expected what was coming next. Just before 2 a.m. on January 23rd, the earth split open. A fissure tore through the east side of Heimaey, growing rapidly from a few hundred feet to over 6,500 feet long, and it was only 650 feet from the edge of town. Lava began spewing out with terrifying force. In minutes, the skies lit up with fountains of molten rock, some blasting up to 490 feet high. At least 40 lava fountains erupted along the fissure, ejecting lava and volcanic debris at a mind-boggling rate of 3,500 cubic feet per second. The eruption was loud, fiery, and apocalyptic in scale. Within 2 days, one dominant crater emerged. It soon built itself into a towering 330-foot cinder cone, later named Eldfell, meaning Fire Mountain. Lava began flowing from it relentlessly, spreading toward the town and threatening to engulf everything in its path. Before the eruption, Eldfell was considered dormant, having not erupted for over 5,900 years. So the people of Heimaey had little reason to worry about volcanic threats. But now they had to act fast. Fortunately, nature gave them a break. A rare westerly wind carried the ash cloud away from town, just long enough to organize an evacuation. Incredibly, a recent storm had forced all the island's fishing boats back into the harbor. That meant there were enough vessels on hand to evacuate most of the 5,300 residents quickly. Within 6 hours of the eruption beginning, nearly everyone had fled the island, by sea or, in some cases, by air. It was a logistical miracle and one of the fastest evacuations of its kind. Despite the scale of the eruption, only one person died, likely due to toxic gas exposure. But the volcano wasn't done. As lava crept toward homes and businesses, firefighters and volunteers worked day and night. They cleared ash from rooftops, boarded up windows, and salvaged what they could from doomed houses. By early February, the situation worsened. Lava flows began to threaten the harbor, the lifeline of Heimaey's economy. The town's fishing industry accounted for about 3% of Iceland's GDP, and the port was its beating heart. If the harbor were sealed off by lava, there would be no reason to return to the island. The stakes were suddenly much higher. Authorities and engineers knew that once the lava reached the harbor, it would solidify, creating a rock barrier that could block ships from entering. Losing the harbor didn't just mean economic collapse for Heimaey. It would ripple across all of Iceland. That's when a radical idea surfaced: cool the lava with seawater. This wasn't entirely new. Small-scale lava cooling had been attempted before in places like Hawaii and Mount Etna, but those efforts had limited success. Iceland, however, was ready to try something far more ambitious. Starting on February 6th, a massive operation was launched. Firefighters and engineers began spraying seawater directly onto the lava flows using high-powered pumps and fire hoses. At first, they pumped around 26 gallons per second. The goal was simple: slow the lava down, redirect it, and by time, as water hit the lava, it turned instantly into thick, billowing steam. The lava changed color and texture before their eyes. From a reddish-black flow of molten rock, it became gray, fractured, and rough, cooling visibly from the outside in. Encouraged by the initial results, they increased the flow rate dramatically. Eventually, over 106 gallons per second were being sprayed onto the lava. For the next 5 months, this operation would continue, one of the largest volcanic interventions ever attempted. The cooled lava began to pile up, forming natural barriers that blocked and redirected the flow. What had seemed like a desperate gamble began to look like a real solution. By May, the lava flow had reached heights between 30 and 69 feet, with some areas peaking at 330 feet thick. It buried roads, homes, and even concrete structures. Around 300 buildings were destroyed, with another 60 to 70 buried under volcanic debris. Ashfall added to the chaos. Some parts of the island were covered by up to 16 feet of tephra, causing roofs to collapse. A water reservoir was obliterated, and the city's power plant was severely damaged. Even a submarine cable supplying electricity was severed. But despite this destruction, the harbor was saved. Thanks to the seawater operation, the lava didn't seal off the crucial entrance. In fact, the hardened lava eventually extended the harbor's landmass, creating a natural breakwater that would later be used for further port development. Lava cools when it loses heat. Seawater, with its high heat capacity, is remarkably effective at absorbing thermal energy. As water hits the lava surface, it instantly boils into steam, carrying away massive amounts of heat. This causes the lava to harden and slow down. In some areas, up to 129,000 square feet of lava were cooled at once. As layers of lava cooled, they formed internal barriers, thickening the flow and eventually causing it to pile up rather than spread further. The operation used more than 6.2 million tons of seawater, and while most of that water turned into steam, it left something behind: salt. Since seawater was used, evaporation caused large salt deposits to accumulate. In total, an estimated 220,000 tons of salt were left behind on the cooled lava, giving parts of the flow a white, crusted appearance that can still be seen today. What happened on Jaime in 1973 remains one of the most extraordinary examples of human resilience and ingenuity in the face of natural disaster. The operation was dangerous, exhausting, and experimental, but it worked. Against the odds, a small island community stood up to a volcano and, in a sense, won. Today, Eldfell stands as a reminder of that battle. The cooled lava field, the expanded harbor, and the white salt scars all tell the story of a town that refused to give up. Visitors can walk on the lava, now hardened into rock, and see the buried houses partially excavated by time and curiosity. Jaime recovered. People returned. Homes were rebuilt. Fishing resumed. And thanks to one of the boldest uses of water in volcanic history, the town and its harbor were saved. Sometimes, the most powerful tool against nature is persistence. And in Iceland's case, a whole lot of seawater. Vast stretches of golden sand slowly turning green, millions of trees planted on barren ground, hundreds of square miles of once lifeless desert transformed into fertile land where farming and life itself can thrive again. This isn't science fiction. It's a real-life environmental revolution led by China, a country that has taken the challenge of turning the uninhabitable into the livable to a whole new level. With the collective effort of local communities, experts, and national authorities, China is reversing decades of damage done to its arid landscapes. And although desertification remains a significant threat, China's large-scale greening projects have shown that even the harshest terrains can be reclaimed. One of the most ambitious of these efforts is centered in the Muas Desert. Here, Chinese citizens planted thousands of saplings directly into the sand, often with little or no water. The idea sounded impossible. So what happened next? Let's find out. Northern China, specifically the Ordos Plateau in the Inner Mongolia Autonomous Region, was once a lush area filled with rivers, lakes, and dense vegetation. It was home to thriving ecosystems and vibrant biodiversity. But over time, human activity took a heavy toll. Deforestation, overgrazing by livestock, and unsustainable farming practices slowly chipped away at the land's fertility. What remained was a vast, expanding desert. By the mid-20th century, the Muas Desert had swallowed up over 16,000 square miles of land. Fertile soil was replaced by shifting dunes and rocky plains. Once productive farmlands turned to dust. The desert became not just a symbol of environmental degradation, but a daily struggle for survival. Take the city of Ulan, for example, located right on the desert's edge. Over the decades, sandstorms repeatedly buried homes, farmland, and roads. The winds were so powerful and frequent that Ulan had to be relocated not once, but 3 times. Harsh winters added another layer of difficulty, with freezing temperatures transforming the desert into a deadly, icy wasteland. Locals would often wake up to find thick layers of sand piled against their doors. Digging out was a daily routine. Abandoned homes, left unprotected, were quickly consumed by the dunes, their roofs and walls slowly disappearing beneath the sand. And all the while, the desert kept growing. Records from Ulan show that in the 100 years leading up to 1949, about 540 square miles of fertile land were overtaken by sand. 6 county-level towns and over 400 villages and settlements were either damaged or lost entirely. By that time, forest and grassland coverage in the region had plummeted to just 1.8%. People considered leaving, but for most, there was nowhere to go. The 1950s and 60s were a time of extreme hardship for China. Following the rise of the People's Republic, the nation underwent a radical transformation, socially, economically, and environmentally. During the Great Leap Forward, traditional farming systems were upended in favor of large-scale collective agriculture, but the methods used were often untested and inefficient. One of the more infamous examples was the Four Pests campaign, a well-intentioned but ultimately disastrous attempt to eliminate rats, flies, mosquitoes, and sparrows. With sparrows nearly wiped out, locust populations exploded, decimating crops and triggering one of the worst famines in human history. By 1959, over 600 million people were living in poverty. That year's harvest was 15% lower than in 1958, and by 1960, agricultural output had dropped to just 70% of what it had been 2 years prior. In purely numeric terms, China's agricultural production fell from 200 million tons in 1958 to only 143.5 million tons by 1960. This crisis only worsened the situation in desert regions like Muas. Starvation forced people to make hard choices: stay and fight the land, or perish. So they fought, but not with weapons, with trees. In the 1950s and 60s, a grassroots movement began to take shape. Locals, determined to reclaim their land, started planting trees by hand, millions of them. Some even sold their livestock to buy saplings, understanding that the animals wouldn't survive without vegetation anyway. One farmer famously sold 84 sheep to buy enough saplings to create a 3.7-mile-long green belt along the southern edge of the Muas Desert. He wasn't alone. Entire families dedicated decades of their lives to planting and nurturing trees. In some cases, 3 generations worked on the same plot of land, slowly turning sand into soil. As the trees took root, they began to change the landscape. Their roots helped stabilize the sand, brought water closer to the surface, and created shade, conditions that encouraged smaller plants and grasses to grow. With every new tree, the next batch had a better chance of survival. The Chinese government supported these efforts. Scientists were brought in to study desertification and recommend solutions. Water-retaining grasses and drought-resistant trees were introduced, and over time, the once unstoppable dunes began to slow. But one major problem remained: moisture, or rather, the lack of it. Most deserts, including Muas, suffer from extremely low rainfall and high evaporation rates. As a result, many planted saplings withered and died, despite the best efforts of locals. That changed in 2004, when a desertification expert proposed a groundbreaking solution. His team introduced a soil hydrodynamic treatment method, essentially preparing the soil in a way that retains moisture and reduces evaporation. The process helps balance the needs of young plants with the water-holding potential of the soil. The result? Survival rates soared. Suddenly, it became possible to plant trees in dry desert soil, without irrigation, and still have them thrive. So what has all this hard work led to? The results are nothing short of miraculous. One powerful photo comparison tells the story best. In 1998, a young boy and his grandfather planted a poplar tree in the Muas Desert. By 2020, both the tree and the boy, now a man, had grown tall. Behind them, what was once a desolate landscape had become a green oasis. Since the beginning of the campaign, over 40 million trees have been planted in the Muas Desert. Species like Glan's larch, a hardy evergreen introduced decades ago, are now thriving thanks to these new techniques. Today, Glan's larch covers more than 330 square miles of the desert. And larch is just the beginning. In nearby Yanwan, on the edge of the Muas Desert, the AI Lavender Ecological Base has become a colorful paradise. Covering over 4,900 acres, the area now blooms with more than 3,000 acres of lavender, plus hundreds of acres of other flowers like verbena and chrysanthemums. Ulan, once a symbol of desertification, now stands as a model of recovery. Forest coverage in the city rose from less than 2% in the 1950s to 33% by 2020. Every year, locals continue to plant thousands more saplings. In 2020 alone, their target was to reforest nearly 1,000 acres of desert. The government and private companies have also joined the fight. In the first quarter of 2020, 41 entities, both public and private, planted trees on more than 82,000 acres of land near Ulan. But what about the bigger picture? Well, the results are even more astonishing. In the 20th century, the Muas Desert stretched across 16,300 square miles. Today, over 93% of that land has been reclaimed, now covered with greenery, thriving ecosystems, and agricultural potential. Once a barren stretch of wasteland, the Muas Desert is rapidly becoming a symbol of resilience, restoration, and hope. While challenges still remain, especially with ongoing climate change, the progress made so far proves that with determination, science, and community effort, even the harshest environments can be brought back to life. So, can deserts be stopped? In China's case, the answer is already growing. The Mekong River, the largest waterway on the Indochina Peninsula, stretches more than 2,500 miles, originating in the Tibetan Plateau and flowing through countries like Myanmar, Laos, Thailand, Cambodia, Vietnam, and China. While this river sustains millions, we're particularly focused on its path through China. Why? Because China has constructed a significant number of dams and hydroelectric plants along the Mekong, some of which are massive. The vast network of dams and hydroelectric plants plays a crucial role in China's energy needs, but as we'll see, it comes with serious consequences for the country's downstream. Let's dive deeper into how these dams are affecting the Mekong and why the situation is drawing alarms. Let's begin by looking at the Xian Dam. This massive structure, located in China's Yunnan province, is an arch dam completed between 2002 and 2010 at a staggering cost of $3.9 billion. Standing at 960 feet tall, it ranks among the 5 highest dams globally. The Xian Reservoir can hold an astonishing 4 trillion gallons of water, with its hydroelectric capacity of 4,200 megawatts. The dam generates 19 terawatt-hours of electricity annually. This power generation helps China save 6.9 million tons of coal each year, cutting 13.5 million tons of CO2 emissions. Yunnan Province is a vital agricultural region for China. Its warm climate supports the growth of crops like tea, coffee, sugarcane, tobacco, and rice, which can be harvested up to 3 times a year. In fact, by 2020, Yunnan had 10 million acres of farmland dedicated to grain cultivation. The province's fertile lands are crucial to China's food security. However, while the reservoir supports agriculture locally, downstream nations are facing far graver consequences due to the dam's operation. The impact of the Xian Dam's operations became glaringly evident after it began functioning in 2011. The following year, an intense drought affected 4 countries, Thailand, Cambodia, Vietnam, and Laos, where nearly 65 million people rely on the Mekong for water and food. The region, heavily dependent on the Mekong, was devastated as water levels dropped, leaving crops unwatered and populations without adequate drinking water. By 2016, Cambodia faced severe water shortages, with 18 out of 25 provinces impacted. In Thailand, 21 people died due to extreme heat, and in Vietnam, nearly 2 million people struggled to find drinking water. The drop in river levels also led to salt water encroaching into the Mekong Delta, devastating 10% of Vietnam's rice crops. China, however, denied responsibility, claiming that the drought was caused by exceptionally dry weather and not by their dams. While the dispute continued, the question remained, was China's assertion accurate? To answer that, we'll look at more recent data. From 2019 to 2021, a significant lack of rainfall worsened drought conditions for the downstream nations. However, the situation was exacerbated by China's dams holding vast amounts of water. Between China's Xian and Huazhou dams, more than 50% of the Mekong's active water reserves were stored. In 2020, the driest year on record, these dams could have alleviated some of the drought's effects by releasing water during the rainy season, but they chose not to. Instead, China prioritized its own needs. In 2019, the Stimson Center, a Washington-based think tank, published a report pointing to China's dams as a primary cause of the drought affecting the Mekong's downstream countries. The report, based on satellite imagery from the company Eyes on Earth, painted a concerning picture. These infrared images clearly demonstrated the drought's progression, revealing that while China's part of the river was well maintained, countries downstream faced severe hardship. In 2019, the Mekong's flow dropped to its lowest levels in a century, making it the worst year for the lower Mekong basin. The consequences were devastating. Failed harvests, declining fish stocks, critical as fish provide a primary protein source for millions, and increased social unrest. Local authorities in the affected countries declared states of emergency, as the damage from the drought was palpable. So, what was happening in China? While the rest of the Mekong River basin suffered, China's dams remained full, and the country's climate was comparatively wetter due to higher than usual rainfall and snowmelt. Yet, most of this water went directly into China's reservoirs, further depleting the flow for downstream nations. This strategy of hoarding water has sparked significant concerns about China's control over the river. In essence, China's dams are disrupting the entire Mekong ecosystem, impacting not only agriculture but also the environment and local communities. For years, China has avoided joining international conventions or agreements that would limit its authority over the Mekong's water resources. Despite the growing dissatisfaction of downstream nations, China maintains that its actions are justified, citing the need for energy production and regional development. In fact, China has consistently rejected claims that their dams are to blame for the diminished flow, including the most recent rebuttal from the Global Times, which defends the dams as crucial, especially during the rainy season. However, other independent studies, such as those conducted by the University of Colorado at Boulder, support the idea that large dams significantly affect regional climates and water flow patterns. In North America, for instance, research spanning over 30 years has shown that the construction of major dams has a direct impact on precipitation patterns and water availability. It's safe to say that the negative effects of dams on the environment are becoming increasingly clear, and China's refusal to acknowledge them is becoming harder to justify. But what happens when China decides to release water from its dams? It's not always the case that water is held back. In fact, sometimes the flow of water from the Mekong's dams increases sharply. During periods of peak electricity demand, China releases stored water, raising the water levels of the river. Even during droughts, a study that analyzed nearly 100 years of hydrological data found that, in recent years, the water levels on the Laos-Cambodia border have risen by 3 to 5 feet during droughts. This artificial increase in water flow has detrimental effects on local ecosystems, especially when it disrupts the natural water cycle. For instance, the trees that typically grow along the riverbanks, which are adapted to seasonal flooding, have been negatively impacted. These trees rely on the fluctuation in water levels for survival, with low water levels allowing new saplings to take root. However, when the water level stays high for too long, it disrupts the growth cycle, causing many trees to die. The same problem extends to the fish, birds, and other wildlife that depend on the forests along the river. While China's actions are certainly damaging, they are not the only contributing factor to the Mekong's problems. Laos, for example, has been rapidly expanding its own hydroelectric industry, building over 60 dams on the Mekong's tributaries by 2016. One of the most significant projects, the Zaiburi Dam, has been the subject of extensive controversy. Environmentalists argue that the dam could severely disrupt fish migration and affect ecosystems downstream. Despite claims from developers that they've taken measures to mitigate the impact, such as installing fish ladders and sediment gates, the river has still suffered. In some areas, the once brown Mekong River has turned an unnatural bright blue, signaling the loss of vital sediment, something known as hungry water, which causes erosion and further environmental damage. The Mekong isn't the only river where hydroelectric projects are causing conflict. A similar scenario is unfolding in Africa, where Ethiopia has built the Grand Renaissance Dam on the Blue Nile. This has sparked a heated dispute with Egypt, which heavily relies on the Nile's waters. Egypt claims that the dam threatens its water security, while Ethiopia argues that the project is crucial for its development and will provide electricity to millions. The situation mirrors the Mekong, where one nation's dam-building ambitions are jeopardizing the future of its neighbors. The situation with the Mekong River presents a complex and multifaceted issue. While hydroelectric power is often seen as a clean energy alternative, the environmental and social costs of large dams cannot be ignored. China's dominance over the Mekong's water resources has sparked tensions with its neighbors, and the long-term consequences of these actions are becoming more evident with each passing year. Until there is greater cooperation and regulation regarding the construction of hydroelectric plants, the future of the Mekong and similar rivers around the world remains uncertain. The need for balanced, sustainable management of these vital water resources has never been more pressing.